This is Geometry Homework 9-1, Solid Figures, Identifying Volume and Area. All right, the first 14, questions. We're just trying to find the name of these. So this one is this prism shape. So prism shapes mean you have some sort of base shape, and then you just kind of come up from there, right? So this is a triangular prism. Again, this one is going to be a prism shape because we have all of these coming up from the ground. It doesn't really matter what you consider to be the ground. These are clearly marked, so I'm guessing that the NSQ wants us to say that this is a square prism. Technically, you could say that this is a rectangular prism. It doesn't matter which side is the base. That could be the base, and that could be the other base, so that would make this a rectangular prism. Rectangular prism. Both of those would work. This next one is definitely a rectangular prism because these two lengths are the same, these two lengths are the same, therefore we have a rectangular prism. Next we have yet another prism shape because we have some base shape, and then coming off of that we have these four parallel lines, and the base shape here is trapezoid, so this is a trapezoidal prism. We got some more prisms down here. These next ones are prisms because it has like a base shape. It has the base shape, and then these lines come directly out, right? The lines come directly out. Those are all called prisms. This one is a pentagon, so pentagonal prism. This one is a hexagon, so a hexagonal prism. Number 7, now the base is still a triangle, so it's triangular something. Triangular, and because these all meet at a point now, that's called a pyramid. Triangular pyramid. Pyramid. There we go. This one has a base shape that is a square, so this one's going to be a square pyramid. This one, the base is a rectangle, so rectangular pyramid. I didn't really mix these up, so I made them nice and easy for you guys. This one's a pentagon, so pentagonal pyramid. This one's a hexagon for the base, so we're going to say hexagonal pyramid. This one is just a cylinder. You just have to know it. Cylinder, I can spell. The general idea here is the base shape is a circle, and then it's kind of like a prism that it extends exactly from that base shape. This one is very similar to like the pyramid, where it's base shape a circle and then it meets to a point. So this is kind of like I want to call this a circular pyramid, but it's really just called a cone. And then finally we have a sphere. Remember that a sphere, technically every single one of these is kind of like made out of glass and it's hollow. Every single one of these is hollow. We're just talking about the actual shape itself, and maybe if that shape can hold volume, like that's the volume of air that we're talking about, but the actual shape itself is always hollow. All right, so these first few are the easier ones. We're finding volume, and then eventually we'll do 2 pages of that, and then we're going to do surface area, and then 2 pages of that. I consider surface area to be far more difficult. Let's jump into our volume question. The general idea behind each volume question is this. We want the volume, and we're going to have some base area, and we're just going to multiply by the height. We have to identify what that base area is on each of these. So on each of these, my base area is kind of unorganized, but my base shape is B down there. If I go ahead and analyze B, I have a triangle that, okay, it's not the best triangle, but thank you, technology, for fixing that. I have a length of this length and this length are the same, so this shorter length is 6. I know that this length and this length are the same, therefore this length right here is going to be 8. And I don't really need it, but if I wanted to, I can say that length is 10. This is one of those special right triangles that you should know, 6, 8, 10. It's kind of like the 3, 4, 5, but doubled, right? 3, 4, 5, yeah. All right, so how do you find the area of that? This is going to be base, I should write this down. This one is base times height divided by 2, or in this case, it's 6 times 8 divided by 2, which is equal to 3 times 8, because again, I did 6 divided by 2 first, and 3 times 8 is 24. So the base area is 24. I can come back up here and say 24 times the height. So this extends up how far? It goes up 4, so I can say times 4. 24 times 4 is just like a double, so double 24, 48, double 48, 96. So we get to 96, and then don't forget our units, centimeters cubed. All volume is power of 3 because we're in the 3rd dimension. I should be checking my work, so 96 centimeters cubed for 15. 15 is 96. 15 is 96. A lot of pages to go. 15 is 96. Let's go. All right. And I think I'm going to check every 2 at a time, and I can come back if I made a mistake. This is a rectangular prism. Again, the base shape I always want to highlight. This is the base shape that I'm seeing right here. And that's B. Again, volume is always going to be base area times the height. The base area in this case, let's do an analysis. The base area is a rectangle, and it's a 12 by a 7, so therefore it's an 84 area. So it's going to be 84 times the height, and the height is coming up, which is a height of 7. I don't know what that is off the top of my head. I am going to be using a calculator for this, so I might as well just pull it open right now. Calculator, scientific. I'm going to put the calculator on the left because I'm right-handed, and I'm just going to do 84 times 7, and we get 588. 588. And what units are we in? We're in kilometers cubed. I'm going to check all 3 of these answers at the very end, and then when I move on the next page, I'll check those, right? All right, this one is a rectangular prism. So rectangular prism, the base shape is confusing to most students because a lot of students are going to say the base shape is this rectangle because it's on the bottom. Base doesn't mean bottom. Base in prism form means it is this shape and this shape. The shapes have to match. This shape down here does not match with that shape up there. They are different, therefore that cannot be the base. The base in our case is going to be, I'm going to call it this shape right out front. It could be the one out back, it doesn't really matter, but that is my base shape right here, B. So I'm going to go ahead and say volume is always going to be base area times height. The base area in this case is going to be a rectangle, which I'm just going to quickly sketch right here. The rectangle has, I guess I drew it upside down. It makes more sense to draw this right side up the way that it is in the drawing. So let me redo this and say the base shape is long, short, short. It goes up like that. All right, so this length is 5. The height right here, it clearly tells us is 3.5, and then that long length is a little bit hard to see, but this long length is 9, this long length is 9, that long length is 9 as well, so 9. The general formula for a trapezoid is you add the 2 opposite sides, so it's going to be 5 plus 9, and then we multiply that by the height, so times 3.5, and then we divide all of that by 2. So that's going to be equal to, calculator, to the ready, set, in parentheses, 5 plus 9, that's a 6, 9, there we go. And then that's going to be multiplied by 3.5, and then I'm going to divide all that by 2, that's fine, and then 24.5. So this is going to be 24.5, which is now my base. So I have 24.5, and I need to multiply that by the height. So the height in this case is what's coming out of our base shape right here. So what's coming out is this, and that is 6. So I'm going to say we're going to multiply by the height of 6. So I'm going to say answer times 6, and that's going to be 147. Units are going to be centimeters cubed. Always power 3 for volume. All right. Moving on to number 18. Again, we need to figure out this base shape. So I'm going to, again, volume is always the same formula over and over. Volume is going to be base area times the height. So the base area is going to be a little bit hard to discuss, but we're going to do it. The base is going to be, I'm going to do my best attempt at drawing a pentagon, more or less, okay? So the pentagon is going to really be made out of triangles. So this first individual triangle, is I'm going to pull it out right here. This triangle has a, oh, that was a terrible dotted line. That is a height of 8.3, and it has a, this base is a little bit hard to see. I'm looking for this number, which is the same as that number, which is the same as that number, which is the same as that number, therefore it's 12, right? So I can say that base is 12. So to find the area here, it's going to be 8.3 times 12, and that all divided by 2. That's going to be 6 times 8.3. So or I can just type in 8.3 times 12, then divided by 2 is 49.8. So 49.8 is our base. Or is a triangle, I apologize, right? This is just one triangle, and how many of these triangles are there? There's a total of 1, 2, 3, 4, 5 of them. So I need to multiply this by 5. So we need to do 5 triangles. So 5 times 49.8. So we're going to come down here and say answer times 5 is going to be 249. Therefore, the area of that pentagon is 249, and I multiply by the height, which is coming out of it, which is 12. So I'm going to say answer times, not divided by, but times 12, and I get 2,988 units are going to be yards, power 3 cubed. Yards cubed. All right. Now I want to check these last three answers to see if we got it right. Oh, I didn't highlight our base shape, did I? So the base shape in this case is this bottom down here. There is our base shape, which I will label B for base shape. All right, let's see what we have so far. 588, 147, and then that number right there. Oops, too far. Let's see, 588, check. 147, check. 2,988, check. Okay, so far so good. Haven't made a mistake. I'm going to make a mistake eventually in this video. It's just a matter of time, right? All right, and number 19, now we've moved on to pyramids. The general idea behind, did I skip a page? I did not skip a page. The general idea behind pyramids is you have volume, which is still base area times height. The only additional thing is you divide it by 3, which I think in the notes I said you put a 1/3 out in front. That's also acceptable, whatever floats your boat or sinks your sub in this case. So first I need to do the base shape. So the base shape in this case is this shape right here, 2, 3, 4, there's 5 sides. 5 sides means we have a pentagon. So this is a pentagonal pyramid if you're interested in the type of shape here. And that means I'm going to be doing an analysis on a pentagon. A pentagon has 5 sides, so there it is. And I have a triangle. Let's go ahead and pull out that triangle. That triangle has a, ooh, it's kind of hard to see, so I'm gonna go ahead and do it up here. This triangle right here has a height of 6.2. So this height right here is 6.2. And it looks like it's 62, so 6.2. And the base is also a little bit hard to see. I'm looking for this base, which is the same as this base, which is the same as this base, which is 9. So this is going to be a 9. So the area of this triangle is base times height, all divided by 2. So what do we have here? 9 times 6.2, and then divided by 2. The area of that triangle is equal to 27.9. How many of those triangles do we have? Again, this is a pentagon, meaning 5. So I have 5 of those triangles, and that's going to be 5 times our answer, which is going to be 27.9, and this is going to be 139.5. All right, so therefore we have our base. I can plug this in. This is going to be 1/3 of the base, which is now 139.5, and I'm going to multiply by the height. The height here is clearly 7 coming up from the center. I can just type this into the calculator, right? So I can say 1/3, and I'm going to multiply that by our answer, and I'm going to multiply that by 7, and I get 325.5. Units here are going to be centimeters to the power of 3. Again, volume is always the power of 3. All right, and then once I do number 20, I'll come and check my work. The general idea here is, again, you have volume is equal to base times height. You always start with that. Because of the pyramid, we're going to have a 1/3 of that. And I need to figure out what the base is. The base shape here is pretty straightforward. It looks like it's a rectangle. That's not a rectangle. Come on, technology. I'm trying to draw a rectangle. There. It's a 10 by 9, which is an area of 90. So this is going to be equal to 1/3 of 90 times the height, which is 9. And that's going to be 270. I can do that in my head. 270 kilometers cubed. And box it. All right, let's check. So 325.5, which is on my calculator, and 270. Let's check that. 270, check, yep, and 325.5. Everything seems to be going good so far. Okay, we're on to number 21. 21 is a sphere, and a sphere, you just have to memorize the volume for formula. Formula is going to be 4/3 pi r cubed. It's just something that you have to memorize. And if you're looking for surface area, you just go like this. Whoop, 2, done. It's just kind of, it's very, very similar, right? So in this case, it's going to be 4/3 pi. The radius here is not 14. 14 is the diameter. Again, the diameter is always twice the radius. So if the diameter is 14, you divide both sides by 2, and the radius is equal to 7, right? So I can say 7 to the power of 3. I just type this into the calculator, and I'm essentially done. So I'm going to type in 4/3, and I multiply that by pi, and then I multiply by 7 cubed. 7 to the power of 3. And I get 1,436. Does it tell us what to round to the instructions? Round to the nearest hundredth, it says up here, which means 2 decimal places. So I'm going to code 2 decimal places, not 7.5, but 7.6. And then units here are going to be centimeters cubed. I'll come and check that after I finish number 22. I don't want to keep flipping back and forth. Number 22 is, again, it kind of looks like a prism, and it basically is the same area or the volume for the prism. It's just going to be base times height, base area times height, again, where you have to think about base is the circle in this case, right? Did I highlight the base shape up here? I want to highlight that because it looks really nice for my notes. Go back. Base is right there. We'll label that with a B. And then the base shape in this one is going to be this circle. That is our base. All right, so that's going to be our B. And the area of a circle is going to be, so I'll talk about this. The area of a circle is pi r squared. In this case, it's going to be pi. R is going to be not 12, but half of 12, which is 6. So 6 squared, which is going to be 36 pi. I'm just going to leave it as 36 pi, so I'll plug that back in. 36 pi, and then I multiply by the height. The height coming off that base is a 9, so I'm just going to type this in. I have 36 pi times 9, and I get, that's going to be equal to 1,017 2 decimal places, so 88 units are going to be kilometers to the power of 3. Okay, let's go ahead and check both those answers. I believe the last two values in the calculator are the answers. They are, so I don't have to memorize them. I got 1436, good, and 1017, good. All right, so far so good. Haven't made a mistake. It's gonna eventually happen, I promise. Moving on to number 23. All right, so these are the harder ones because there's more work involved. This is the surface area of each figure. So surface area means you have to find the area of each of the sides. There's a lot of work that goes into each of these. The first one might be a little bit easier because we have two of this shape. So maybe I can use technology to make this look a little bit nicer. So I have two of that shape. I have, it looks like this shape right here. We have four of this shape. So this shape is a 2 by 2. So this area is 4. So this is going to turn into 2 times 4. This shape is an 8 by a 2, which is an area of 16. So really I have 4 times a 16. 8 and 64. And 8 plus 64 is a 72. So the final answer here is going to be 72, and then units are going to be kilometers. We're talking about area now, so it's switched from cube to squared. So 72 kilometers squared. I'll check that in a little bit, but I think that looks good so far. All right, number 24, we have this prism that's a triangular prism. So what sort of shapes do we have? We have this shape right here that has a dashed line right there. We have two of those, right? We have the top and the bottom, and we have a bunch of different rectangles. We have this rectangle. That's supposed to be a rectangle. We have this rectangle. We have this rectangle. And we have this rectangle. I'm just randomly drawing rectangles, if I'm being honest, guys. We have one of those, and one of those. You guys see all of the ones I'm talking about? First of all, we have the triangle. The triangle, the one that I'm seeing... Here, let's move the laser pointer. This is the base of the triangle, and this is the dashed height. This is the base, this is the dashed height. We all see it. This base is this base, therefore that base is 12. I'm going to come down here and label this 12, and the height is labeled 7.1, which means this is going to be 2 times, okay, the area of a triangle is going to be base times height, all of that divided by 2. And interestingly, that 2 and that 2 cancel each other out, which is kind of fun, and this is just 12 times 7.1, so 12 times 7.1 is 85.2. So this is going to be equal to 85.2. All right, the first rectangle that I'm seeing, I'm just randomly saying that is the first rectangle. That's a 11 by 9. So I'm going to say this one is going to be 11 by 9, which is 99. So let's add that to the list, 99. The next one that I see is I should write it down with the laser pointer so you guys can see as well, is this one. That's a 9 by 12. So let's go ahead and label that. That's a 9 by 12. That's going to be, what is that, 108, I think? I hope it is. If I get the answer wrong, that's where I messed up. I'm only like 4 out of 5 on my 12s. And the next one that I see is this rectangle back here, which is an 8 by 9. So I'm going to go ahead and label this one 8 by 9. Obviously not to scale. 8 times 9 is 72. And add 72 to the list. All right, that is all the area. I just have to add each of these up. So I'm going to do this with the calculator because why not? So I'm going to take that answer plus 99 plus 108 plus 72. All right, my final answer, when I add all of my surface areas, I get 364.2 units. Here are going to be feet, so we're in feet to the power of 2, feet to the power of 2, because we are in the second dimension for area. Let's check those two answers. 72 and 364, that's on the calculator, so just remember 72. 72, good. 364.2, good. All right, we haven't made a mistake, which is very unlikely, but here we go. Number 25, time for a mistake. All right, so the first thing that I'm seeing is we have a trapezoid. So we have one of those. We have one in the back, so I really have two of those. I have a bunch of rectangles. So I think I have a total of, there's going to be 1, 2, 3, and 4. So 4 rectangles. I'm just going to randomly draw 4 rectangles. I think are they all different? They might be. I don't know. I'm just going to draw 4. I can calculate. That's supposed to be a rectangle. I promise. There's 4 rectangles. Let's do the trapezoid first. So the trapezoid has this height here of 4.3. One of the bases is 6. The other base is 11. The formula for this one, there's still 2 copies of this, is base 1 plus base 2, all of that times the height, and then divided by 2. And yet again, these 2 canceled out, which is kind of nice, isn't it? So really what I have to do is 17, what am I going to type here? 17 times 4.3. And that's just 73.1. So answer here is 73.1. That's what I get when I have 2 trapezoids. The first rectangle, I'm going to do the one on the very top here. It's kind of tedious to go between laser pointers because it's so far over. But this one on the top is a 10 by an 11. So I'm going to say 10 by 11, which is 110. Easy peasy, 110. I love rectangles, they're so easy. Okay, next one I have this one and this one. That's 5 by whatever that length is, 10. So it's 5 by 10. So I'm just going to say 5 and 10, just putting them in random spots. That's clearly 50, add it to the list. The next one that I see is this bottom one down here. That's a 6 by that length, which is 10. So it's 6 by 10. So we're going to say this one is a 6 by 10, which is 60. All right, so add that to the list. And the last one that I see is this rectangle right there, which is 10 by that length, which is, it says this length and this length are the same, so that means it's actually a 5. It's a 10 by 5, which really means, this 10 by 5, there's 2 of those. So I'm going to come back here and say, really, there are 2 of those, so 2 times 50 is actually 100. So I'm going to come back here and say, you're really 100, and that means I don't have this other rectangle because of the congruence. All right, so what do we really have here? If I add all these up, that's going to be 210, 270. So this number, this is going to be answer plus 270. Let's just double check the 270. Yep, 270. If I add all these together, according to my math, we get 343.1. What are our units here? This is going to be kilometers. So kilometers, we're dealing with area, so it's power of 2. Area is always in the second dimension. Excellent. Moving on to number 26. What do we got here? Okay, so we've got a pentagon, and I'm already seeing the triangle of the pentagon. So let's go ahead and redraw that shape. We have actually we're gonna have 2 of these, aren't we? Boom, 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 boom. We have 2 of those pentagons. That has a triangle right there. So let me do some analysis on that triangle. That triangle right here is really this height here is a 6.9, and then the base, okay, it's kind of hard to see, but it says that this length is 10, which has a tick mark, and if all of these are the same length, then all of these have to be the same length. That's what it means to be a prism. So that means that this length down here is that 10. So I'm going to come down here and say that that base is 10. And the area of a triangle is 1/2 base, which I was about to write B, but 1/2 base, which is 10, times the height, which is 6.9. And that is the individual triangle, which I'm just going to do with the calculator. So 1/2 of 10 is 5, so it's 5 times 6.9, which is 34.5. So this area of the triangle is 34.5. The problem is there are 5 of those, so 5 triangles is 5 times 34.5, which is, and I need to multiply that by 2 because there's 2 copies of that, don't I? So here we go. I'm going to take that answer, 34.5, and I'll multiply it by 10. I didn't need to multiply by 10 in the calculator because I can just move a decimal point. That's 345. So there's 345 miles squared of area between the top pentagon and the bottom pentagon. So 2 pentagons, right? Each pentagon, this was 1 pentagon, and then I multiplied by 2 to get 2 pentagons. The only thing that's remaining, the nice thing about prisms is all of these should be the same. They're all the same rectangle. So I'm going to go ahead and draw that rectangle. That rectangle is a 4 by 10. 4 by 10. And how many do we have? Well, it's a pentagon, so we have 5 copies of that. So this is 40. So 5 times 40 is 200. And we need to add that to our list. So I have a 200 over here, and I'm adding our list. 200 plus 345 is 545. Man, my handwriting in the bottom left or bottom right corner is atrocious. 545, slightly better. What are our units here? Miles. So miles, and we're talking about area, so power of 2 because area is always the second dimension. All right, let's check those. So I have 343.1 and 545. 343.1 and 545. I still have not made a mistake. This is crazy. All right, we're on our last. Is it really the last page? Only 4 more problems. Wow, 4 more problems. My mistake's gonna happen here, right? Here we go. All right, so I'm seeing that this is a pyramid, which means I really just have this hexagon. This hexagon has a triangle right there. There's really only 1 copy of that hexagon, so I don't have to worry about 2 copies of the hexagon. If I do the analysis on the triangle, it's supposed to be a triangle, the height of that triangle is a 7.8, and the base of that triangle is 9. Why? Because this length over here is 9, this length is 9, this length is 9. They all have tick marks, right? That means that this length is also 9. All right, so the formula for a triangle is base times height, all of that divided by 2 for a triangle. So I'll say this is 9 times 7.8, and then I divide that by 2, and the area of that one triangle is 35.1. How many triangles are there? Well, this is a hexagon, so there should be 6 of those. So I really need 6 times that 35.1. So I'm just going to say 6 times the answer, and I get 210.6. All right, next I have these really long triangles. They have a base of 9 that I already discussed, and they have this this height right here of 13.5. So I'm going to come down here and say this is really a height of 13.5. All right, so the area of a triangle, oh, how many copies of this? It's a hexagon, so we have 6 copies of that, right? So this is going to be 6 times, okay, here comes the area of the triangle. So base times height divided by 2. I'm just going to type this into the calculator, right? 6 times 9 times 13.5 divided by 2, and I get 364.5. Adding that together, there's a 1, carry the 1, that's a 5. There's a decimal place, no carrying, it's a 7 and a 5. I get 575.1 units here are going to be inches squared for my final answer. And again, I'm adding up all of those numbers up there. All right, another pyramid. This time it is a pentagonal pyramid. There we go, because it's a pentagon. So first I have the pentagon, which I'm going to attempt to draw right there. So that pentagon will have a triangle, which I will do the analysis. There's only 1 copy of this, by the way, so I'm going to go ahead and look at the triangle, and I have a height of 4.8. It has a base of 7. It's going to be 1/2 base times height, and that's going to be the area of the triangle, so let's just type you in. We have 1/2 of the base times the height, and I get 16.8. 16.8. And how many of those do I have? I have 5 of those because it's a pentagon. So 5 of the 16.8 triangles. So I'm going to say 5 of those is going to be 84. So 84 so far. And then I have to do, that's the base shape. Now I need to do the lateral area. The lateral area, aka the non-base area, is a bunch of triangles. It's 5 of those triangles. So let's go ahead and redraw like a skinny looking triangle. There's 5 of those triangles. And how many triangles, or what are the dimensions? I have 12.9 and 7. So this is a 12.9 right here by 7. This is going to be 5 times the 12, I guess base times height, so if I want to do it in the right order, it's 5 times 7 times 12.9, all of that divided by 2. Just type it in the calculator, right? We have a 5 times 7.9, and then, 7.9, what am I doing? 7 times 12.9, there we go, divided by 2, and that's going to be equal to 225.75, and then I need to add that with 84, so I'm just going to add it right now, plus, not there, add it right now, plus the answer from above, and I get, if I add these all up, I get 309.75. What are our units in this case? It's going to be inches, so inches squared, so whoa. This is going to be inches. Where's my answer? Oh, there it is. Inches squared. So I'm going to move you so I have some room right there. Inches squared for my final answer, which I'm in a box because it's kind of hard to find my answer, as I clearly just showed. So I have to remember 575.1, 575.1, and 309.75. 309.75. Okay. Last one, surface area for this one is just a formula, volume. Oh, I was about to write volume. The surface area of a sphere, instead of 4/3, it's just 4. And then instead of pi r cubed, it's pi r squared. It's going to be 4 pi, and then the radius in this case, it already told us it's 6.8. We don't even have to divide by 2 to get from the diameter to the radius. And I just type this into the calculator, I'm done. 4 pi, and then I have 6.8 to the power of 2. And this is going to be equal to 581.07. Units are going to be centimeters squared. Final answer, box that one. How are we doing in 29? 581.07. Oh my God. And then the last one I'm going to get wrong. That's just because I know that the answer key is incorrect. It's ambiguous as to what this 12.6 is talking about. Is the 12.6 talking about this slant height? Is it talking about the height if it were to go to the center? It's not clear. And I think I'm going to be writing a message to the people that made the curriculum, this program. To me, it looks like this height is 12.6. So that's the way that I'm going to interpret it. What I really have here is there is a triangle, and I'm going to outline this in blue because it's an important triangle. It's a right triangle, might I add. And I'm going to redraw this out here so you can see it a little bit better. That is a terrible interpretation of that triangle, Mr. Sindel. There we go. So I have this triangle that is a right triangle that is 8 by 12.6. And the problem with triangles is, well, I guess the problem with this problem in general is I need this height because height is one of the key characteristics of finding the surface area. So how are we going to do that? And I'm realizing that this is not a volume question, it's a surface area question. I was about to... Okay, so hold on. Everything that I've said so far is correct but unhelpful. Because really what's happening here is we have two things, right? We have a net where we have a circle as one of the two things, and we have this shape that I think Charlie described as a fan. I'm going to try my best. Please? Nope. Okay, I'm going to go like that, and then... That's essentially what the cone is going to look like. And to make sure that you really understand what's going on, if I glue you to you and I wrap it all the way around, then this is going to be the tip of the cone, and this shape will perfectly fit because this length right here is the same as this length right here. I hope that makes sense. If it doesn't, I apologize. This problem is really hard. I'm not going to put it on the quiz because we forgot to go over this unit. We skipped it. But what essentially I have here is this is a piece of a circle, and I did a terrible drawing, but what should really happen here, I have new technology. This app just got updated. Check this out. I'm going to do a dashed line. Thank you. And watch this. Really what you should have here is a circle. That is a piece of that circle. Let's come back to my solid line. So what we really have here is and it tells us this length right here is 12.6. So I'm going to say this length right here is, oh my goodness, 12.6. I'm going to do it in red though. 12.6. And we also know that this radius over here is 4. That's the information that has been given to us. So how do we figure out this problem? There is a volume, or there is a formula for the area, but I'm going to go ahead and rederive everything from scratch. So we know that this has a circumference. So this circle's circumference, aka the perimeter, is equal to 2 pi r. If you didn't know it, now you do. So the circumference is 2 pi r, which means the circumference here is 8 pi. That means if this circle were to roll from here to here, this total distance would roll 8 pi, because exactly one of this is exactly one of this. They have to match up perfectly. That's the definition of the net of a cone, which means this distance is 8 pi. It's kind of interesting, right? So this distance here to here, I'm going to label, it's 8 pi. So why is that important? It's because I can figure out what the entire perimeter or circumference is of the big circle. The big circle, if it were completed, the circumference would be 2 pi r. In this case, it would be 2 pi, and the radius is 12.6. In this case, what do we have? It would be 2 pi times 12.6. It would be equal to 79.16. 17 if I'm rounding correctly, right? But there's a problem. I don't have the entire circumference, do I? I have only 8 pi of my 79.19. In fact, can I just make this easier? Can I get rid of that pi so I can talk about this without pi? 2 times, so it's 25.2 pi's, because the pi's are going to cancel out. That's why I wanted to do it this way. So really what I have here is a, wait, 25? 12.6, yeah, that's right, okay, 25, I was doing a sanity check there. 25.2 pi, that's the entire circumference. So I'm going to do this. I'm going to figure out the partial over the entire to figure out the percent. This is equal to the percent. The percent of the circle is the partial, which is 8 pi, over the entire, which is 25.2 pi, and the pi's and pi's are going to cancel each other out, meaning my percent is 8 over 25.2. What is that, calculator? 8 divided by 25.2 is that percent, which is a fraction of 20 over 63. I'm just going to call this a percent. It's going to be 30, or I guess it's 0.31746. I don't know where to round, so I'm just going to write a bunch of stuff. That's the percent of the circle, which means I can find the entire area of the circle, because the area of that circle is pi r squared, which I know very well. It's going to be pi times the radius, which is 12.6. I'm going to square that. I'm going to get, what do I get? I'm going to say 12.6 squared. I'm going to get, I'm going to add the pi on at the end because I don't like including pi until the very end. This is going to be 158.76 pi. That is the entire area. There's a problem though. Do I want the entire area? Do I want this entire area of this circle? No, I just want this piece of the circle. Just that piece, which means I need to talk about the percent. I know the percent of the circle that I'm using. I'm using that percent of that entire area. So here's where I go. I'm going to come down here and say, now I need to multiply it by the percent. So if I multiply it by the 0.31746, I'll figure out the area of that little piece over here, which I'm going to erase some stuff so I can actually see what's going on. So now I'm going to say, this is going to be multiplied by our previous answer, which is exactly 50.4. This is exactly equal to 50.4. Don't forget your pi. 50.4 pi. The area, and it's kind of cool, we haven't talked about this yet, the area of this semicircle is 50.4 pi. I just need to add it with the area of this circle, which I haven't done yet. The area of this circle is going to be pi r squared, which is going to be equal to pi times 4 squared, which is going to be 16 pi. So if I have 16 pi and another 50.4 pi's, and I add them together, 16 pi, right? 16 pi. If I add these two together, I'm left with 66.4 pi. And now I can multiply by pi. So what is 66.4 pi? 66.4 pi is, there we go. This is equal to, I want to do the equal to right here. This is equal to 208.60, but I'm just going to say 60, I guess. And finally, what are the units? The units are in centimeters. So centimeters, and it's power of 2 because we are in the second dimension. Did we get it right? 208.6? 208.6. I thought the answer key was wrong when I was helping you guys, and then I realized this problem is way harder than I thought. If I had an honors geometry, this would have gone on the honors geometry, but because I don't have that, I'm going to exclude that from the quizzes and the tests. That was a fun problem though. All right, that concludes our homework. What homework were we even working on? Homework 9-1. Thank you for watching, and I'll see you guys later.